Alright guys, so now we are still on a section 6.7, but now I'm going to focus on trying to solve the problem number 23. So on the problem number 23, we have two equations, y equal x plus 9 and y equal minus x plus 11. And the question is to solve the system of equation by substitution. What does that mean? That means that I'm going to, from one of these two equations, isolate one of the variable and then substitute the variable in the other equation. And in that case, pretty simple. Y is already isolated, so what I'm going to do is I'm going to substitute the value of y by the expression y right there. And so at the end of the day, I end up to have a x plus 9 equal minus x plus 11. So that gives me, if I isolate x on everywhere, and if I want to subtract 9 like this, now I have on one side only the variable, on the other side a non-variable, because right there the x disappear and right there the 9 disappear. I end up to have 2x equal 2, and so x equal 1. Now, because x equal 1, I can substitute x in both equations, and I'm supposed to find exactly the same value of y. So when I look at the first equation, y equal x plus 9, y equal, oops, it's supposed to be a 1. So y equal 1 plus 9, which is going to be y equal 10. But if I decide to use the other equation, y equal negative 1 plus 11, and obviously I found exactly the same value of y. And so the solution for the system of equation is x equal 1, y equal 10. Now, I can try to do the same thing for another one, and let's try to do problem number 28. On the problem number 28, what do I have? I got x plus y equal 3, and then a y plus x equal 5. Well, if I don't see that right away, I'm going to end up to have a no solution, and so we're saying that it's an inconsistent system. What I'm going to do is apply the same philosophy. I'm going to isolate one of the two variables, and because you are so used to manipulate y equal mx plus b, you are going to try to isolate y, and see you trying to isolate y from the equation number 1. So from the equation number 1, you isolate y by subtracting x both sides, and if you're subtracting x both sides, you end up to have 3 minus x. Then you are going to substitute this y into the equation number 2. Okay? So into the equation number 2, you are going to take this y and substitute it inside. And what you end up to have is a 3 minus x plus x equal 5. I guess you can see that 3 equal 5, it's not possible. And so this is why we are saying that this system is no solution, and we're saying that it's an inconsistent system. Now, let's try to solve now the problem number 35. And if I want to solve the problem number 35, it's because it's about solving the system equation by addition method. So, I'm getting a x plus y, and I'm getting a 3x minus y. For the first equation, it's equal to 4, and for the second, it's going to be equal to 8. When you try to solve by adding, what you try to do is try to eliminate one of the two variables, and in that case, by adding both equations. And what's going to happen in that case, if you add these two equations, you end up to have 4x equal 12. And so now you get x equal 12 divided by 4, which is 3. Because now you have the value of x, you can substitute the value of x in one of these two equations. Why not using the first equation? 3 plus y equal 4, so y equal 4 minus 3, which is 1. And so the solution is going to be 3, 1. That is going to be your solution. Okay? It was pretty easy to figure it out that if I add these two equations, y will be disappear. But I could do it by trying to make x disappear. So let's try to do that with the problem number 35. So let me write again the problem number 35. We have x plus y equal 4, and then we have 3x minus y equal 8. Well, obviously, if I want to get rid of the x, I need to multiply the first line by 3, and I need to multiply by negative 3. By doing so, I end up to have, now, the first line, the second line doesn't change, 3x minus y equal 8, but the first line is becoming a negative 3x, negative 3y equal negative 12. Now, if I decide to add these two equations, what do I got? Well, you got the x disappear, and you got minus 4y equal negative 4. Because negative 12 plus 8 equal negative 4. So y equal 1. Now you got the value of y equal 1. You substitute the value of y equal 1 inside your first or the second equation. I take the first because it's pretty simple. X plus y equal 4. And I end up to have x plus 1 equal 4. So x equal 3. And you realize that this time I decided to isolate and get rid of x, and I end up to have exactly the same solution, which is the point coordinate 3, 1. Alright guys, so now in order for me to end this section 6.7, what I want to do is try to solve the problem number 45 with you. So let me do the problem number 45 with you. Number 45, we're having the equation 4x minus 2y equals 6, and we're having the other equation 4y equal 8x minus 12. Well, what I want to do is pretty simple. First I'm going to rewrite the equation number 2 by making sure that I have 4x minus 2y equals 6, and my equation number 2 with x right there and y right here. For that, I'm going to end up to have minus 8x plus 4y equal negative 12. I just decided to subtract minus 8x both sides and then realign x under the x, y under the y. Now, I'm going to multiply by 2 this line right here. I'm going to multiply by 2 this line right there, because by multiplying by 2, I end up to have now 8x minus 4y equal 12. And I rewrite my other line, which is negative 8x plus 4y equal negative 12. Now, if I decide to add these two equations by addition, what do I end up to have? Well, I end up to have is the x disappear and the y disappear. So I end up to have 0 equals 0. Okay? 0 equals 0. And that means there is an infinite number of solutions. Infinite number of solutions. Okay? And we define that as a dependent system. Dependent system. Okay? So if you have 0 equals 0, 2 equals 2, 4 equals 4, you end up to say it's an infinite number of solutions dependent system. Okay?